Hi there, check out this animation, right? What's happening? He does this X, so that means multiplication. And what happens? When he does that, he multiplies, right? And then suddenly he disappears. So you multiply so that something will disappear. So that's the topic for today, multiplying two equations so that eventually we could eliminate one variable to solve systems of equations. Are you ready? Here we go. All right, before anything else, let's review what we've learned in the past. Okay, so we've learned the following methods, graphing methods, right? Remember y equals mx plus b. If your equations is in that format, you can graph it and you can visually see where they meet up. Substitution, okay? Substitute a variable with an expression and then you could solve for x and the other variable. Substitution. For in this case, y is equal to a value and y is equal to the same value. So make this equal to that so that you can solve for x. Next, we did addition and elimination, right? If it is set up like there's a negative 2x on top and a positive 2x below in those equations, you could easily eliminate them and then just add them up. If you do that, you can solve for a variable, then solve for the other variable. But the problem is this, you cannot eliminate. So in that case, you have to multiply first. So multiplication so that you can go back to addition and elimination. Are you ready? Okay. So remember, given a system of equations with different coefficients for each variable, meaning look at this. Like for example, the first one is 3x plus 9y equals 12. And then the other one is 4x minus 2y equals 18. Look at this. They are different. They are different. Okay? Different coefficient for each of the x and the y. So guess what? Multiply both of them by a number, a constant, so that you could remove the x. Or you could multiply also both of them by a constant again so that the y could be eliminated. Once you eliminate either the x or y, then you could solve for the value. It's going back to the old method. For this equation, look at this. It's kind of weird because it's different from elimination. Look at the coefficient of x. It's a 3 and you're a 2. How can I cancel it? You're a 5, you're a negative 2. How can I cancel it? So let's think of a number that we can cancel it with. Okay, now, guess what? Think of a wish list. Let's focus on the x's first. Look at the x's. 3 and 2. Think of the multiples of 3. 3, 6, 9, 12. Think of the multiples of 2. 2, 4, 6, 8, 10. What is their LCM? Where did they meet? They meet at what? Okay, they meet at 6. All right. So let me write 6. 6. If only 3x was a 6x, and 2x is a 6x. Of course, you want one of them to be a negative. Suppose I want the first one to be a negative, right? Okay. How will I make you negative 6x? How will I make you positive 6x? Okay. So to make you a negative 6x, I have to multiply. That's why it's called multiplication. I multiply you by what? Negative 2, right? 3 times negative 2 is negative 6. 2 became a 6. Multiply by what? By 3. Yes, think of that. I multiply the first one by negative 2. I multiply the second one by positive 3. But guess what? You're not just multiplying to one term. It will not make it equal. You have to multiply it by all of them. All right? What do you mean by that? Write the negative 2 here. Write the positive 3 there. Why? Because you'll have to multiply it to each term. We did the first one, negative 6. Let's do the second one. Negative 2 times 5 is a negative 10. Let's write it down here. Negative 10y Negative 2 times 27 is negative 54. Equal sign, negative 54. See, we're multiplying now. U3, we did that already. That's why we got the 6x. 3 times negative 2 is a negative 6y. 3 times 2 is a 6, positive 6. Guess what? What did we do? We transformed the first equation to another equation, but they're still equal because we multiplied it by a specific number. We use negative 2 and positive 3. Why did we do that? Because look at this. It will make our life easier. We could cancel that. We could eliminate it, and that becomes 0. Therefore, what was our method before? Simply add the top and the bottom. That becomes negative 16y is equal to negative 48. Add the top and the bottom. Okay? Next, divided by negative 16, divided by negative 16 cancels out. Y is equal to what? 3. Now I know the value of y. Thank you. So repeat multiplication first so that you can eliminate and do your addition rule. Okay, now, since I know the y, I could either use equation 1 or equation 2. Suppose I want to use equation 2. Use equation 2 and substitute the value of y. All right, so let's use it then. 2x minus 2y equals 2. So 2x minus 2 times, instead of using y, I use the number 3. All right, is equal to 2. 2x is negative 6 equals 2. Two-step equation, plus 6 for you, plus 6 for you. That becomes 2x equals 8. What's next? Divided by 2 on the left, divided by 2 on the right. Even though you could do this mentally, please write it down. X is equal to 4. So you already solved for the x and the y. Put them together. Your solution would be, start with the x, 4, then with the y, 3. So that's my solution. Okay, got it? That's just example 1. Let's have a second one. Okay, let's try the next one. Okay, let's try the next one. So 4x minus 2y equals 4, and the other is 2x plus y equals 6. Okay, a while ago we eliminated the x. Guess what? You can also eliminate the y. It doesn't have to be the x all the time. Now, focus on the y. You're a negative 2y, you're just a positive y, right? If only, if only you're a negative 2y, I can eliminate you, right? If only, I mean a positive 2y, right? How can I make it positive 2y? Obviously, you'll have to multiply the whole thing by 2. Okay? So let's do that. 2 times 2 for x. 2 times y is 2y. 2 times 6 equals 12. All right. So I changed the second one. But the first one, do I need to change you? No. I can just copy you for x minus 2y equals 4. And then what? Guess, look at this, guys. I can eliminate my y. So what remains is 4 plus 4 is 8x is equal to 16. One-step equation, divide by 8, divide by 8, cancels out. X is equal to 2. All right. So, see, multiplication, it doesn't have to be for both. It could just be for one of the equation. Since I already know the x, I will now solve for y. Solve for y. I could use equation 1 or equation 2. Okay? Let's say I want to use equation 1. So let's reuse for x minus 2y equals 4. Since I already know x, you're not x anymore, you're a 2. minus 2y equals 4. That's going to be 8 minus 2y equals 4. Get away, positive 8, minus 8 for you, minus 8 for you. That cancels out. Negative 2y equals negative 4. Get away, times negative 2. Divide to the left yo, divide to the right yo. That cancels out. 4 divided by 2 is 2. Negative divided by negative is positive. So what's our answer now? We have an x value of 2. We have a y value of 2. So that's our solution. Are you sure, Ram? Okay, so let's do a checking. Use any equation, 1 or 2. Let's now use 2 probably. All right, 2x plus y, is it equal to 6? 2 times, oh, I know you're a 2. Y, I know you're a 2. Okay, but is it equal to 6? 2 times 2 is a 4 plus the 2, is it equal to 6? The left side is 6, the right side is 6. Check. So you know you are right. You're a smart kid. You don't need RAM anymore. Okay? All right, let's try this. Okay, so I will have to use my multiplication. You're a 5, you're a 2. I want to make 10. Okay? I'm going to make you a 10, so times 2. I'm going to make you a negative 10. I'm going to make you a negative 10, so times negative 5. All right, so let's do that. 10x, we're doing distributive now, plus 10y equals 10 times 2, 20. All right. So multiply each part. So you're going to be a negative 10x minus 10y equals negative 20. That cancels out 0. That cancels out 0. That cancels out 0. Is 0 equals to 0? That's true. So what do we learn about that? There is infinite number of solutions. Okay, so not that. Let's try the second one. All right, I see a 3 and a 4. Where will 3 and 4 meet? 3, 6, 9, 12, 4, 8, 12. So they will meet at 12. Okay, I want to make you a 12. Okay, to make 3 a 12, I will multiply by what? By 4. Okay, by 4. So you will now become a 12x. 4 times negative 6 is negative 24y. 4 times 4 is what? 16. Okay, now, we want to make it 12, right? For you to become a negative 12, not positive, because you want opposite sign, I will have to multiply you by 3. All right? So everything now will be times 3. So negative 12x, 3 times 8 is 24. 24 positive. 3 times 7 is what? 21. Okay, remember the y there. And then now, guess what? I can cancel the x. But the problem is I can also cancel the y. So what remains on the left side? 0. 21 plus 16 is 37. Is 0 equal to 37? False. That can never happen. So, is there a solution that will make 0 and 37 equal? Never will that be equal. Okay? So, there is no solution. No solution. Remember, if the left side is different from the right side, there is no solution. So, this is our answer. Next. Okay, so the scout sold small and large boxes of cookies. Let's call the small the X and large the Y. One scout sold 7 small and 12 large boxes for a price of 54. Check this out. They wrote it as an equation for you already. It makes our life easier. Another scout sold 5 small X and 10 large boxes Y, which is an equal of $60. See that? They wrote the equation for you already. The scout leader wrote a system of equations to represent their sales, okay, which contains each equation be multiplied by so that one variable is eliminated. Our objective is to eliminate. When the equations are added, check all that apply. So there's more than one answer. So let's start with multiplying the first one by 5 and the second one by -6. Let's start multiplying by 5. 7 times 5 is a 35. 12 times 5 is a 60. I'm not writing the x and y anymore. 540 times 5 is 270. Okay? The next one is multiplying by -6. Okay? This was multiplied to the first, then this was multiplied to the second. Okay? So let's do the second equation. -6 times 5 is -30. -6 times 10 is -60. -6 times 60 is -360. Guess what? We can already cancel these two. So it can work, right? I could do that. So you're okay. Now, let's try the second one. Let's try multiplying by -5. It's the same as our first set, right? Let's just make it negative. -35, -60, -270. Then the second one, so the first one again, this was multiplied to the second one. Okay. 6 times 5. Oh, it's the same as the previous, but now positive. So positive 30, positive 60, and positive 360. Okay, guess what? You can cancel these two. So that's okay. I can use that for elimination. So the next one, let's try multiplying the first one by -5. All right, we did that already. -35, -60, -270, right? And the second one is multiplied by 7. Oh, we haven't multiplied by 7. So let's do that now. 5 times 7 is 35. 10 times 7 is 70. 60 times 7 is 420. Okay, look at this. You can cancel that. So good. I can use that. Let's try the next one. Let me use the purple. First one is times 5. Okay, we did that already, just like the one in red. 35, 60, 270. All right. Then multiply by -70 the second one. The second one. So -7, we did that already, right? -7. Oh, not yet. So it's the opposite of this one. So -35, -70, -420. Look at this. You can eliminate. So that works. Let's try the last one. Let me use light blue, -5. We did -5 already, like the green one. -35, -60, and -270. All right, times 10. That's easy. You're going to be a 50. You're going to be a 500. No, 10 times 10 is 100. My bad. And then times 10, 60 is 600. Is there any number that I can eliminate here, the top and the bottom? Nothing to eliminate, so not you. So the first four are our answers because you can use elimination using those numbers. Now, this question is like a summary of what we've been doing so far. Now, what are the steps commonly used to solve systems of equation with two variables? Which steps are correct? And let's see. Number one, multiply the value of the first variable by one of the original equations to solve for the second variable, right? You solve for x first, and then you solve for the y. Yes, we did that. Use multiplication to write an equivalent equation, which is opposite terms, so that you can eliminate. Yes, we did that. Solve one of the variables, of course. Solve x first, and then solve for y, or the reverse. Did we write the opposite of one variable so that we could solve the other? For example, there's a 3x. Did we just write positive 3x? No, you can't just do that. You'll have to multiply it by something. You cannot just write the opposite. No. Add the equivalent system of equations so that we can eliminate. Add the bottom top and add the bottom, right? So that you can eliminate. Yes, we did that. Write the second the as an ordered pair, the solution as an ordered pair. At the end, we wrote the x comma y. Yes, we did that. Substitute the value of the known variable. You already know the x or y to the original equations, to one of them, right? The first or the second, so that you could solve for the other. Yes, we did that. So those are the correct answers. All right, this is the last problem. Joanna wrote the system of equation. If the second equation is multiplied by 4, all right? So she used times 4. So let's do that. The second equation will be 4 times 5 is 20x. 4 times 4 is 16y equals 4 times 9 is 36. Okay, we're good with the first one. Question is, what should the first equation be multiplied by to eliminate the x by addition? So I want to eliminate 20x. What do I need? I need an opposite of that, negative 20x. How can you become a negative 20x? What will I multiply you with? 4 times 5, yes. Is it times 5 only? No, it has to be negative. Therefore, it's times negative 5. Everything will be times negative 5. So the next one would be negative times negative, positive 15y, and then negative 5, right? So that I can eliminate this one and that one. So our answer is negative 5. All right? Got it, guys? So remember, results is equal to action plus motivation. All right? Good luck.